All right, you guys. Hey, sorry I had to leave early. Kiddo is sick, so I just had to run out. So I don't have a super lot of time to prep something for you. But this is the information that I would have been giving you at the beginning of class. So it's not like going to quite be a traditional ed puzzle with feedback and things like that and questions. Because I don't have time to get that together for you before you come in. But I did want to get through the material. So first, I would like for you just to take a minute or so and practice some electron configurations. So go ahead. The video is going to stop. Do this, and then when you're done, the answers will be there for you. Okay. All right, so here are the answers for you. So nickel is right here. So it's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d8. All right, then we had rubidium, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s1. Then you had barium, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2. And this is as far as you'll ever have to go. Okay, we won't go into the Fs. And then iodine, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p, 1, 2, 3, 4, 5. Okay? So again, there are those answers for you. Pause if you need to. All right, so then I want to get some terminology in place. It's something called valence electrons. Valence electrons are the electrons in the outermost energy level, also known as the highest energy level. Okay, so the electrons in that highest energy level or outermost, either language is fine. And so you'll notice here I have the orbital notation for sulfur. So remember that when you are writing these orbital notations and things like that, these threes out in front, okay, are representing your energy level, right? So when we say 1s, 2s, 2p, 3s, 3p, 4s, those first numbers that you're saying are the energy levels for those elements. So even if you were writing something out like 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p5, right? That was iodine. Or not iodine, sorry, that is bromine. When you are looking at this, the 4s2 and 4p5, that is your highest energy level. The 3 is technically a lower energy level. So even for something like bromine here, that 4s2, 4p5, those are your valence electrons, okay? So again, you're always looking at that highest energy level number that you have. Okay, so those are your valence. So scientists were like, okay, great. So let's talk about valence electrons. Let's make electron configuration a little bit easier and use something that we call the noble gas configuration. So the noble gas configuration is going to be a shorter way to even write electron configuration. So first it was orbital notation. They wanted to make that shorter. So then they made electron configuration. They wanted to make that shorter. And so now we have this noble gas configuration here. So noble gas, what does that even mean? Noble gases, they are the elements in this last column of the periodic table. And so notice that when you are talking about the noble gases like neon ends in 2s2, 2p6, argon, 3s2, 3p6, krypton, 4s2, 3d10, 4p6. So they all, when you're getting to those noble gases, you're always at the end of a row, okay? And so you fill everything in that row to have a noble gas. So scientists were like, cool, let's make electron configuration even shorter. So humor me and go ahead and take a beat and write the electron configurations for these elements listed here. All right, so sodium, 1s2, 2s2, 2p6, 3s1, 1s2, 2s2, 2p6, 3s2, and phosphorus, 1s2, 2s2, 2p6, 3s2, and 3p3. So when you look at those 3 electron configurations in order, notice that this part, and this part is identical for all 3, right? Anything after 2p6 has that 1s2, 2s2, 2p6 part at the beginning. And 1s2, 2s2, 2p6, if you look at the periodic table, 1s2, 2s2, 2p6 is element neon. So scientists, in their ever-loving way to make things easier, were like, let's just say it's neon 3s1. Let's call this neon 3s2, and this friend, neon 3s2, 3p3. Okay, and so it's just a shorter way. Imagine doing something like barium. Barium, right? Like, let's look back at this friend. Barium was so long. Well, 5p6, right? If we cut it off there, that's the noble gas that occurs before the valence electrons. 5p6 is xenon. So instead of writing all of that out, you could just write xenon 6s2. Whew, so much better. So I would like you all to take a second and do these, please. Okay, so here are your correct answers for these. So again, chromium right here, you find the noble gas on the row before was argon, 4s2, 3d4. Then for cesium, you find the noble gas on the row before, Xe, 6s1. And then oxygen, find the noble gas on the row before, is helium. So helium, 2s2, 2p, 1, 2, 3, 4. Okay. All right, so ions, as a reminder, let's see, we introduced ions when we talked about isotopes. We did ions last class with orbital notation. Now I want to talk about ions with electron configuration. So just a reminder that ions are going to be an atom with a charge, okay? It can be positive or negative, okay? And that charge happens when an atom has more or less electrons than protons, okay? So it's an atom with a charge, and it happens when there are more or less electrons. So what does it mean to have a positive charge? So when an atom has a positive charge, that means that there are that many less electrons in the atom. Again, if something has a positive charge, that means there are that many less electrons. And so what happens is, whatever the charge is, it means the atom has lost that many electrons. So if something has a positive 2 charge, it lost 2 electrons. Positive 3, it lost 3 electrons. Positive 1, it lost 1 electron. Okay, so again, with that positive charge, there are going to be that many less electrons, and you look at the charge to figure out how many less electrons there would be. If something has a negative charge, that means there are more electrons than protons in the atom. So again, if there's a negative 1 charge, there's 1 more electron. Negative 2 charge, 2 more electrons. Negative 3 charge, 3 more electrons. Okay, and so you're going to be using the charge of those ions to figure out if you need to add or remove electrons. And this leads us beautifully into bonding, which is our next unit. So taking a look here, I am told that calcium has a +2 charge. So I look at that, and that tells me that I'm going to that there are 2 less electrons. So I would do the normal electron configuration for calcium, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. So that's normal calcium. And then I think to myself, okay, because it has a positive 2 charge, that means I need 2 less electrons. So I take those away. And that would be the correct answer for calcium with a +2 charge. Let's look at another one together. Sulfur with a -2 charge tells me that there are 2 more electrons. So while sulfur is normally 1s2, 2s2, 2p6, 3s2, 3p4, that's normal regular sulfur. Because it has a -2 charge, I'm going to need 2 more electrons there. So I get rid of that 4. 4 plus 2 is 6. Okay, so I would like for you to go ahead and do nitrogen. All right, so nitrogen is normally that 1s2, 2s2, 2p3. Because it has a -3 charge, I know that means there are 3 more electrons, so that 2p becomes 2p6. So there you go. That's the end of the new information.